Hi everyone, we are Group F and this is our final presentation of this semester and our first presenter Taesung. And this is our context and I'm going to talk about microelectronic circuit and each context members will talk about. And this is research done by the science Donga and we can know the electromagnetics and semiconductor and transistor were ranked high for the greatest physics in history. And this figure, we all know the battery is made up of proton and electrons and neutron. And proton and electrons has polarized and it very similar gravity. It has force. So and that force is the base of energy source of electromagnetic circuit. And this is the advantage of the microelectronic circuit. It features the lights thin, short, and small. So it has high reliability and high economical efficiency and high performances. So we can make the passive and active devices. And this is history of semiconductor advancement. And in 20th century, the development of semiconductor will grow rapidly, and the industry also grow rapidly. And nowadays, the gauge length of most devices reach down to 19 nanometer for ASIC, and this is the picture of ASIC. And this is silicon ingot, and from this we can make a silicon wafer. And if the dicing the silicon ingot, we can get a silicon wafer like this, and we pattern the wafer using photorisography technology. And this is reticle. We pattern the circuits on this reticle, and we pattern the circuit on wafer. And we also studied the resistor, capacitor, and BJT and MOS transistor. And this table shows the difference of silicon and gallium nitride. We can check the silicon has bad mobility and gallium nitride has a very good mobility. And this is Moore's law, and it is very famous theory.
Hi, I'm second presenter Joo Kim. And integrated circuit can be separated in two types. First is bipolar and second is MOSFET. And if you draw the table in quality, then you will get a table of like this. And so as I mentioned before, so you can check that this is separated by this bipolar and MOSFET, and there are 5 techniques in bipolar and 3 techniques in MOSFET. And if you combine these 2 techniques, then you will get BiMOS and BiNMOS and BiCMOS. And as you see here, the power consumption is here and this is power consumption and this is the propagation time, and power consumption is really important. So most of people use CMOS. And this by making this integrated circuit, you can make integrated circuit by 2 plans. First is structural hierarchy and second is abstraction. And in abstraction part, then you need to make C program, choose the CAN, and input output deliver quality. Logical combo intrinsic circuit diagram, then you can make a layout. And second, topology. In topology process, you can make connection of circuit elements, then you can connect the polygons. So you will get layout like this. This is VDD and this part is ground. To make integrated circuit, then there are some process. And first is making a wafer production, and next is wafer test and sorting, and chip assembly and chip test. There are 3 types in integrated circuit time. First is in standard integrated circuit, and second is with microphone integrated circuit, and finally older style integrated circuit. And if you and there are 3 development of integrated circuit. First is standard integrated circuit, and second is micro integrated circuit, and finally is older style integrated circuit. Then you can classification like this, and in ASIC you can separate in 2 types: AESSP and AESCP, and there are 3 types: in full custom IC, semi-custom IC, and field programmable logic IC.
I'm the third presenter, and I would like to introduce VLSS design application, especially integrated circuit. It has a 3 types of ordered IC, first full ordered IC and the semi-ordered IC and the user program IC. It is a very important part of semi-ordered IC because it has an FPGA and the cell and the combination of the array. And the VLSI design. It is necessary to expense the two types of expense. First is fixed expense and the second is incremental expense. First, fixed expense has the cash charge and the make generation and back cost and engineering cost. And the problem of volume level expense makes the incremental expense and the market pressure and manufacture cost. And we already studied the logic gate of a combination of logic, XOR and OR gate. And finally, we make a backend layout. I explain back to the page, semi-ordered IC and full-order IC and gate array IC. And the VLSS plan. The VLSS process plans has the 5 types of process. First, algorithm level design and the verification. It is more important because it has a high position level synthesis and verification and schedule and allocation and input, act plan and output, until level structure plan data. And second, functional level design and verification. It has a logic level synthesis and verification which has the very difficult logic gate. And the VLSS plan. The gate level design and verification is already we have to do in the Namyeon Kim study is simulator because it is the test pattern generator and fault coverage simulation. And next, it is the picture of the digital logic gate and analog logic gate. The right side is digital logic gate, and left side has the one of the NA and peak detector and RS frost ends and error pass. It is a network of analog logic gate. This picture is I talked back page, and it is left side is RF and analog, and right side is digital. And it's a combination of the capacitor and resistor, and it has so many blocks in the RBEE. And it has 5 steps, and it has first is the direction of input and the output of each block, and second is the size of each block, and third is noise coupling and the interference from internal block. And finally we do the simulator, and later we do the chip packaging. It has a die attached barrier and ground bonds and CU lead frame. And downboard, it is important to make the current flow in these semiconductor chips. Thank you.
There are some examples for the packaging here. Here is some techniques for the TSOP package and QFN package. Another example, CSP and BGA packaging here. BGA package we use ball grid like this picture. We use ball to hold the chip on the PCB board. Here is the COB package. This package makes the lowest height of the system, so it uses small volume of the chip on the this PCB board. Here is another example, SIP. This alternate solution for the SoC because we put the chips on the we couple up the chips on the this one molding, so that's why we can alter this SIP. I mean, we can alter SoC by this technique. Here is the SMT. We put capacitor and resistor and inductor outside of the chip. This is techniques for this SMT. There are so many chips on the PCB board, so we need to design these chips how to put these chips on the PCB board very effective. Thank you.
여기까지인데? 네, 또
그 레볼루션.